morning to all. So today class we'll be discussing about a very simple easy trick to find out whether the given compound is Closo, Nido or Arachno according to the Wade's rule. The another name of Wade's rule is polyhedral skeletal electron pair. See here, electron pair theory. So this theory basically provides the electron counting which is very useful to predict the structure of clusters like carboranes, boranes or main group clusters also. So let's see the question. The first question is using Wade's rule predict the structure of B5H9. Here if you see B5H9, so first thing we have to see the PEC calculation. What is mean by PEC here? PEC means that is a polyhedral electron count. You can calculate PEC, polyhedral electron count, by using the formula that is a valence shell electrons upon 2. So if you consider B5H9, it is having total 5 BH fragments and 4 extra hydrogens. So we know each BH fragment contribute 2 electrons. So 5 multiply with 2 plus each hydrogen contribute 1 electron. So 4 multiply with 1. So total it is becoming as 14. So 14 upon 2, the value coming it as 7. 7 means the B5H9 where n is 5. So it obeys the rule of n plus 2. So that's why the compound according to the Wade's rule it is said to be as a Nido. So option B is the right answer. Now the second question, the dodecaborate ion that is a B12H12 2 minus ECA. So as we know we can write it as a B12H12 as BH12 2 minus. So you know each BH fragment is 2 electron contributing. So 12 multiply with 2 and minus 2 means it has gained 2 electrons. So total extra 2 electrons we are going to add here. So the total is becoming it as 24 plus 2 26 upon 2. So it is coming it as a 13. So according to the Wade's rule it obeys n is 12. So it obeys the rule of n plus 1. So that means the compound is said to be Closo. So this compound is categorized as Closo borane. Next, the third example also you can see based on the Wade's rule of electron counting, structure of carborane. So for the carborane also same rule is applicable, that is a polyhedral electron count can be calculated as total valence shell electrons upon 2. So here each carbon is 6 and which is equals to the BH, that is a 5 plus 1 isoelectronic, and you can say here B8H14. So the B8H14 can be written as what? So that I can written as BH8 and here another BH coming from the carbon. Instead of carbon you can write this is a B9H15, right? So in that case you can write BH9 plus the extra how many hydrogens are there here along with 6 hydrogens. So total 9 multiply with 2 plus 6. So it is equals to the, so total it is 18 plus 6, so 24. So which is equals to 24 plus 2 is equals to 12. So here if you see the overall value is coming it as a 12. So 12, but actually n value you can write it as this compound. The C is isoelectronic with BH, so I am writing B9H15. N value is 9. So but here we are getting it as 12. So that means the 9 plus 3 we are getting it as 12. So n plus 3. So it is obeys the n plus 3 rule. So the compound is said to be Arachno. And we can also apply the same rule for this one. So based on the Wade's rule electron counting, the structure of carborane that is a CB8H14. Same only here. Sorry, same question repeated. So you can also say this is also a Arachno compound because you can write this also B9H15. If suppose they are asking to find out whether the given main group element structure or D block complexes, if they are asking what to do. For example, in this case according to the Wade's-Mingo's rule you can say 4n plus 2, 14n plus 2. If the given cluster is having 14n plus 2 skeletal electrons, then that is said to be Closo. If it is 14n plus 4, then that is said to be Nido. If it is 14n plus 6, then that is said to be Arachno. Here what does mean by n here? N indicates the number of transition elements, okay, or else the number of main group elements. So let us consider the rhodium 6 CO60. In the rhodium 6 CO16, how many transition elements are there? 6. And first we will count the total valence electrons of this one. Each rhodium is contributing 9 electrons as we know, right? So cobalt group, this is a cobalt, rhodium, iridium. So D7 4:9. Out of 9, each rhodium is contributing 9. So 6 multiply with 9 because 6 rhodium is present. And each carbonyl is contributing 2 electrons. So 16 multiply with 2. So total electrons becoming it as 54 plus 32, which is equals to 86. So the 86 value we used to get if you substitute n as 6, 14 multiply with 6. So here if you get here 14n, 6 plus 2. So we know that 14 multiply with 6 plus 2, it is coming it as 86. So that indicates what? So it obeys the 14n plus 2 rule. So this compound is said to be Closo. For example, if it is a main group element, so for the main group element like S4 plus 2, you will use the formula that is 4n plus 2 and 4n plus 4 and 4n plus 6. Let's see the compound S4 2 plus. Sulfur provides 6 electrons. How many sulfur? 4 sulfurs are there. So that means each sulfur is contributing 6 electrons. 4 multiply with 6 and plus 2, that means it loses 2 electrons. So total 24 minus 2, 22. So if you substitute 4 out of these 3 formulas, where you will get 22 value? For example, if I am substituting 4n plus 2, n as 4. So 4 multiply with 4 plus 2, so it is coming only 18. So it is not the right. If I substitute this one, 4 multiply with 4 plus 6. So which is coming it as exactly 22. That means the compound is said to be Arachno. So in this way we can predict whether the given main group cluster or T block metal complex or else the borane or carborane, we can predict easily whether it is Closo, Nido or Arachno compound. Thanks for watching this video.